Okay. If f and g are continuous functions with f greater than g throughout the interval from a to b, and it is a closed interval, so it includes those endpoints, then the area between the curves is the integral from a to b of f of x minus g of x. F of x minus g of x is important. Which one is which? It's the upper curve minus the lower curve. Literally, the one above minus the one below. It makes no difference whether things are above the x-axis, below the x-axis. It does not matter. It matters the relationship between the two curves themselves. So if one's above and one's below, it doesn't matter. If they're both below, it doesn't matter. If they're both above, it doesn't matter. It's which one's higher, which one's lower. Literally. Which one has greater value at a particular point. Now, my first notion is to draw a diagram for every problem. Even if you're not given it on your homework, it will say find the area between the two curves and it will give you the two equations. And you've got to figure out which one's which. And we'll do a couple along those lines as we go through this. Okay, this one's actually pretty nice and straightforward. I want to find the area of the enclosed region R. What that means is I want to find that. What's that area right there? What's that shape? What's that area going to be? So I need to know a few things. I need to know which one's my upper curve, which one's my lower curve. This one's not too bad. One's a straight line, one's a parabola. I can tell by the equation, straight line and parabola. The parabola curves downward with a straight line underneath it. I know which one's which just based on the diagram. If I don't have a diagram, I still got to figure it out one way or another. We'll talk about that here in a second. But it's not too terribly difficult. The other thing I need to know is, I need to know where my A is, and I need to know where my B is. I need to know my bounds for my integrals. Okay. Sometimes you're given the bounds. Often, or I should say most often, you're not given the bounds. They're not that hard to find. What I have here is I have a system of equations. This is not a system of linear equations. This is not 2x plus 3y equals 5 and 4x minus 5y equals 2. And I got to find my x and y. But this is a system of equations. And something that saved my hiney when I was taking physics in college was understanding that if a system of equations has a solution, because not all systems have solutions, but if there is a solution to the problem, as long as the number of equations is at least as many as the number of variables I have, I can solve for the system. So if I have 2 variables, I need 2 equations. If I have 3 variables, I need 3 equations. If I have 4 variables, I need 4 equations. In physics, you're describing a system. I remember a particular problem. You have a rope tied around a dresser. At what point pulling on the rope with a certain amount of force does the dresser start to tip over, and you're given the parameters and such. And so there's different equations that involve all that stuff. As long as I had these things that I didn't know, and I had this many equations to go with it, I could figure out those things. As long as you have the number of variables, the number of equations is the same or more than the number of variables you have, you can solve the equation. I have 2 equations. I got 2 variables. I can solve this system. I can figure out my x and y. And this one actually is very easy to do. Y equals negative x plus 2. Y equals negative x squared plus 4. Ooh, I have 2 things both equal to y. That means they are equal to each other. That's all. They're both equal to y. That means they have to be equal to each other, right? What property? Transitive property? I think that's what that is. Something like reflexive. One of those properties. Okay. Ooh, I have a quadratic. What do I need to do? Set it equal to 0. Add x squared, subtract 4. 0 equals x squared minus x minus 2. If you're lucky, these will be factorable. 0 equals x minus 2, x plus 1. So x equals -1 and positive 2. Those are the x coordinates. I can find the y coordinates, but I don't really need them because I'm just dealing with my x coordinates for my bounds. So what do I have? I have my bounds. These are my bounds. I have my two equations. So I have to write my integral. So I have the integral from -1 to 2 of the upper curve, -x squared plus 4, minus the lower curve, -x plus 2, dx. Two or 3 point question on the AP exam. Usually what they do is they give 1 point for having the correct bounds and any constants of integration, and the constants of integration we will discuss in the next portion. Okay, when we get to volume. Okay, and then you get, it's either 1 or 2 points for this. Often it's 1 point for having the bounds, because often the bounds are the same in every problem. You get 1 point for getting them right somewhere. Okay, this is worth usually 2 points, minus 1 point for each error. So if you swap them, that's an error. If you put a plus, that's an error. Now, they won't give you negative points, but you can get 0 points for it. And if you get 0 points, they will not compute the answer, and then you get 1 point for the answer. That's usually what they do. Sometimes it will say write the integral but do not solve. I don't do that, but they will. I think I do that on one question on the test, maybe. But AP, I've seen that, and I'm sure that's because it's either really hard to solve, or they just want to know, or they've already used up the rest of the points of the question except for that one answer point. That's what they do. Okay. Now, as far as I'm concerned, in this chapter, pull out your calculator and do this on your calculator. Or you can do it by hand. I don't care. I want to see this, and I want the answer to go with it. Now, if you want to do this by hand, and even if you're doing this on your calculator, I would simplify this down first. Integral from -1 to 2 of -x squared, and then distribute the negative, and then I get plus x. And then I have -2 and positive 4 plus 2 dx. And it's a polynomial, so it's easy enough to do the antiderivatives and do it that way. And plug in the upper bound, plug in the lower bound, and solve it. And where did I leave my notes? Because I worked these out ahead of time, because I'm no fool. This is one of the ones I do ahead of time. And you get 9/2. Yes?
Can you tell which ones are the lower and upper bounds?
Lower bound, upper bound.
From
the curve? Okay, well, if you have a diagram, you can tell from this. This one's easy enough to tell because I've got a parabola opening down, and I've got a straight line. This is a parabola, that's a straight line. I know which one's above and which one's below. Now, if you don't have the diagram, let's say you just have the information, you didn't have the picture. Sketch the picture, get an idea what it's like. Ooh, this is a parabola opening down because it's a -x squared, so I know it opens down. That's a straight line. It's going to cross it somewhere. It's probably going to be that. But if I want to test and make sure which one's the upper curve, which one's the lower curve, you pick a number between the bounds and plug them into the equation and see which one gives you a bigger value. So, for example, if I plug 0, because 0 is between -1 and 2, right? If I take 0 and plug it into this, I get 2. Take 0, plug it into that, I get 4. Which one's more? 4. So this is my upper curve. This is my lower curve because at the point, somewhere point in between, it literally has a higher value, y value and a lower y value. That's what you do. You plug some point in between the bounds into the two equations, whichever one gives you a higher y, that's the upper curve. Whichever one gives you a smaller y, that's the lower curve. Okay, so you can always test that. And when I say sketch drawing, it doesn't have to be exact. You know, for this one, literally, for this, I'd say, okay, I've got a parabola, I've got a straight line. That gives me an idea what I'm looking at. More than likely, it's going to be this. In theory, you could have that. But it doesn't cross each other, so I would have to have some other indication what the bounds are. We'll have a problem like that coming up. Still find the area between the two curves, but I'm given the bounds. Which means I got to figure out which one's the upper one, which one's the lower one at that point. In which case I do plug a number in between the two bounds and figure it out. Okay. Questions on this? Okay. Next one. There are actually 3 different ways to solve this problem. And we will explore all 3 methods for solving this problem. Find the enclosed region R. I didn't do this, but your textbook has this. And what it'll be is it has all these curves, and it'll say there's region R. Region R is the area enclosed by those curves. I have 3 equations. I want to know my points of intersection. So this is the point 2, 0. This is the point 4, 2, and then the origin. That's my other point of intersection. You want to know those because that's where your bounds are going to come from, are going to be those points. The XY coordinates from them. Okay. Now, if I do this as the square root of x minus x minus 2, if I have the integral of the square root of x minus 2, which is my line, I'm going to include not just this region here, but I'm going to include all of this crap too. Is that part of what my problem is? Particularly if I go from 0 to 4, that's going to include everything. I don't want everything. I can't do everything. I don't want to do that. So what I have to do is I've got to figure out how to find this. And you may or may not remember from geometry, but there is a postulate, theorem, whatever, I don't remember exactly which one it is, an axiom, definition, something along those lines, that says you can take an area of an object and break it into parts, and the area of the whole is equal to the sum of the areas of the parts. Or you can take things away. You can do that. So for example, one of the ways to do this is to find the area of this whole thing and then subtract from it this. And that'll give me the part I'm looking for, right? Okay. So I can take the upper curve, and that would be the square root of x dx. Because my upper curve is the square root of x. What's my lower curve? My lower curve is the x-axis. And the equation for the x-axis is y equals 0. So technically I have a minus 0, but we mathematicians are lazy. If it's minus 0, we don't write it. Because you don't need to, it's redundant. Something that's redundant we don't write because we're lazy. And my bounds would be from 0 to 4. And that gives me this entire region here. Everything underneath this curve, the square root, from 0 to 4. It gives me that whole wedge. I don't want the whole wedge. I want this minus something else. And there are 2 ways to do that problem. I could do it as the integral from 2, from 2, not 0. From 2 to 4, let's do this. 2 to 4 of x minus 2 dx. Because that's what this area is here. But let's say I'm lazy and I really don't want to do another integral. What shape is this? It's a triangle. Oh my God, why do an integral when I can do, ooh, that's minus 1/2 times 2 times 2. Really, that's a lot easier, isn't it? Taking the antiderivative, that's even easier than typing it into your calculator, letting your calculator take the integral. Either way works fine, doesn't matter. Both are perfectly legitimate ways of finding the area underneath that curve. So what I'm doing is I'm taking this big thing here, and I am subtracting from that this triangle, and then I'm getting that piece there that I'm looking for. That's what you get. And that would be 10/3. Okay. One way of tackling that problem. Doing an integral minus either another integral or a triangle area, either one would work for your second part. Big piece minus the little piece. One way to do it. Another way to do it is to find the area of that and add the area of that. Break it up into 2 parts and add the 2 parts together. That would work too, right? So for the first one, I have the integral from 0 to 2, because this is 2, that's 4, from 0 to 2 of the square root of x dx. And that'll give me everything between the curve and the x-axis, plus the integral from 2 to 4, and this is a little trickier, the upper curve, square root of x, minus the lower curve, x minus 2 dx, and you would have that. And you know what? It's still 10/3. This is still the same area, just a different way of doing it. Which way would what would I do? Kind of depends upon what's going on. Sometimes you have to break it up into parts like this. This one has a lot of choices to it. Some don't have this many choices to them. Okay. I mentioned there's a third way. Does everybody understand the first 2 ways so far? First one, big one minus a little wedge. This one, little wedge plus a little wedge equals the whole great big wedge. Okay. Next one, everybody stand up. Stand up. Stand up. Look at the board and tilt your head sideways. Tilt your head sideways. We can do this dy instead of dx. Not everything needs to be done in terms of x. We can do this in terms of y. And what's the difference between doing it in terms of y and in terms of x? It's either turning your head sideways or rotating your textbook, as the case may be. Please take a seat. But literally, and sometimes this is what you have to do. Sometimes you have no choice in the matter. You have to do things dy instead of dx. Depends on the equations you have. This one I could have done, this one is not necessarily that way, but I can do it with one integral, dy, where I had to do 2 integrals or an integral and another thing. I had to figure out 2 parts for dx. dy, I can do this as one. I have my upper curve here and my lower curve here. Because with dy, the upper curve is the one that's the farthest to the right. It's the one that has the highest x value as compared to the lowest x value. But I do have an issue. These equations are not in terms of that, terms of y, they're in terms of x. So I have to take them and rewrite them as x equals. But sometimes it's harder to do than others. Sometimes it's really hard to do. This one's not so bad. So I have that one equation there, then I have y equals x minus 2, which means that x equals y plus 2. Okay, does that make sense? So I'm doing it dy, I have to have y. I can't do dy with x's. Can't do dx's with y. They have to match. And if I'm doing it in terms of y, I have to do it this way. Because my bounds go from here to here. Lower bound, upper bound. My bounds switch. When I was doing it dx, my bounds went along the x-axis. I do it dy, my bounds go along the y-axis. So I'm going from 0 to 2. Upper curve, lower curve. Like I said, if you rotate your head sideways, it makes sense. Very easy to see. So the integral from 0 to 2 of y plus 2, my upper curve, minus y squared, my lower curve, dy. One integral instead of an integral and either another integral or another formula. I can do it with one problem rather than two problems. Which one's better? I don't know. Doesn't really matter. Because you get the same answer no matter which one you do. If this was a test question, I really wouldn't care. Solve the freaking problem, give me the correct answer using the correct good math. That's what I'd want to see. Okay? To me, it doesn't really matter which one you use. And I will be perfectly honest, on some of the questions you will have on this test, there is more than one way to find the answer to the question. And I have more than one solution on my answer keys. So it doesn't really matter. Okay. Here's what I'm looking for on these problems. I'm looking for this. And then that. I need to see the original setup, and I need to see the final answer. You can do this by hand, no problem. You can type it in your calculator and have your calculator do it for you. I don't care. The emphasis of Chapter 8 is, can you write the equation to go with the problem? That's the emphasis for Chapter 8. The answer is almost irrelevant. Okay? Almost. Not completely, but almost. If this was a 4-point question, there's one, here's the rest of it right here. Okay? And that's literally, that's how it's done. And I looked for the bounds, I looked for, do you have the right equations, and do you have them in the right places? And when we get to volumes, it'd be a little more complicated. Okay. Questions so far? It's not terribly difficult. There are parts to it. What do you need to do? You need to be able to find your bounds. You need to be able to figure out which curve is the one that's going to come first, which curve is the one that's going to second, which is your F, which is your G. Okay. And then you got to solve the equation one way or another. I cannot overemphasize, your first step on many of these will be to draw a diagram. Even if you have the diagram in your textbook, copy the diagram on your homework and draw on it. When you take the AP test, if they give you a diagram, you can write all over your AP test. You can write all over it. They will not grade the free response questions, the question portion. They will grade the answer sheet that you write your answers on. but label and draw diagrams all over that test question, because they give you a booklet that has the questions in it. I used to get the booklets back, and it was always interesting to see which students actually took my word to heart and actually drew on the questions, and those that didn't, and usually those that did got better scores. Just saying. Not always, but usually. So, find the area between the curves y equals x, y equals negative 2x on the interval from negative 2 to 2. I want you to do this, but I want you to do it step by step. Step number 1, draw a diagram. Draw and label a diagram. I want you to do that first. Don't worry about. Okay. Now, by sketching a diagram, I mean, here's your x and y axis. If it's appropriate, if the equation's big enough, you don't necessarily need an x and y axis. And then because I can do it, I will add a color change. Draw the line y equals x. Draw the line y equals negative 2x. And then where are my bounds? They go from negative 2 to 2. So what area am I doing? That's the area I am doing. That's a good enough sketch. Doesn't have to be perfect. I got the 2 lines. I have my bounds. This is what I'm looking for. This one's a little different than the other 2. Which one's my upper curve? Depends. Which side of 0 am I on? Because on the positive side of 0, it's y equals x. On the negative side of 0, it's negative 2x. It depends. So my upper curves change, which means that I need to do what? I need to split it up into 2 problems. I can't do one integral. Because to be able to do one integral, my upper curve needs to be the upper curve for everything. In order to do one integral, it has to be the same upper curve and the same lower curve throughout the whole problem. I don't. It switches which one's which. This is y equals x. This is y equals negative 2x. They cross in the middle of my area I'm trying to find. So they change which one's the upper and which one's the lower bound. And that is an important thing to understand. So I can find it piecewise, find it by parts. Okay. Go ahead. Find the parts. Okay. So, if you look at this, you have the integral from negative 2 to 0 of negative 2x minus x dx plus the integral from 0 to 2 of x minus negative 2x dx, which is the integral from negative 2 to 0 of negative 3x dx plus the integral from 0 to 2 of 3x dx, which if you do this by hand, it's negative 3x squared over 2 from negative 2 to 0 plus 3x squared over 2 from 0 to 2. And I'm moving over here for a little bit of room. So that's 0, because when I plug in 0 for x, I get 0, minus negative 3 times negative 2 squared over 2 plus 3 times 2 squared over 2 minus 0, which gives us 6 plus 6. which gives us 12. Now, a clever person would have noticed that, hey, that is the same area as this because they are symmetrical. And so you only have to solve one and then double it. In which we get the same thing. Right? Solve one, you get 6, double it, you get 12. But they are exactly half and half. They're exactly the same area for both of them because it is symmetrical. That doesn't always work, but that will often work. Pay close attention to what the equations are. Straight lines, it happens more than curves. Depends upon where the curve is divided at. You might get it with the curve too, but depends upon where they're divided at. But you can always say, hey, wait a minute, symmetrical. I'm only going to do one integral per half because that's easy. And then double that area. And that'll work. Okay? Nothing wrong with that. Trust me, some of these are going to be fun and interesting.
So if there's questions on a test and you didn't specify the use of integral and you just found area which one works,
you would have to use integration. I don't think any of them are full straight lines anyways. Yeah, I think I'd say use integration anyways, which means you would have to do the integrals. But I see your point, find it. But finding the area on this one isn't by doing a triangle. You're still going to have to do some pretty good work on that anyways. Because you're going to have to do 1/2 base times height. So you got to figure out what the base and the height are.
because what I did was I saw that like triangles that are diagonal from each other the same thing.
Okay, but these 2 points are not parallel. They're not straight across from each other.
No, I know.
Okay.
I'm saying like, so you have the bottom left triangle, right?
Yeah.
So you find this, find that.
Yeah, find that, and you don't have to divide it by half or anything. You can just treat it like
Yeah.
square.
And you can do that. And I'll be honest with you, on the AP test, if they gave you something like that and you answered it by using geometry only, no calculus, they've done that where they've written a problem that could be solved by something other than using calculus. And their rule is, as long as it's good math, and if they don't specify what you need to use, they're okay with it. If they specify you must use a particular method, solve using the fundamental theorem of calculus, solve using integrals or something like that, you must use what they tell you. If they don't tell you, you can do any good math that works. And they will give you full credit, even if the answer doesn't match theirs. But you get the correct answer and you use good math, didn't get lucky, so to speak, because that does happen, they'll give you full credit. Okay. All right. So I have those 2 curves. I want you to find the area. Now, before I throw you into the deep end of the pool, let me give you a couple of water wings, which really aren't a whole lot of help, but they're a little bit. Okay, you have 2 sideways parabolas. You absolutely cannot do this in terms of x. For one thing, well, actually, this one isn't so bad, but there's often ones where you cannot do it because the upper curve and the lower curve are the exact same equation. You could do this dx, but the problem doing it dx is you'd have to rewrite this equation in terms of x. Yeah, good luck with that. Same thing on this one. So you're going to want a dy because you don't want to try to rewrite it. There are ones that I've seen, and this will happen in your textbook, where you have a parabola like this and a parabola like that. And at this point here, the upper bound and the lower bound are the same curve. And if you use f of x minus f of x, what's your area? It's 0. It doesn't work. So you could not do it dx even if you could rewrite them that way. This one you can't rewrite them, so it doesn't matter. So you're going to do it dy, which means you need to find the y coordinates of intersection. Works just like the d coordinates, only your x coordinates, only you're doing it with y's instead of x's. Which one's the upper curve? Which one's the lower curve? Take a look at the y squares. Remember, in any Remember end behavior models? Remember end behavior models? End behavior models, the largest part of the polynomial, the largest power dictates what it looks like. So if x squared is the biggest one, or in this case y squared is your largest, it's going to look the same no matter what the rest of it is. The rest of it just kind of makes it a little wider, skinnier, and moves things up and down and around, but it's still going to look the same. So the first one here is y squared. Which way is y squared going to open?
To the upper right.
Which way is negative y squared going to open? So which one's your upper curve and which one's your lower curve based on the negative and the positive y squared? That will tell you which one's which. Okay? Does that make sense? So use those clues to help you out. Okay? Use those clues to help you figure out what's going on. So set up an integral, solve. Find the bounds first. We did an example similar to this at the beginning. Find the bounds. Write the integral. Give me an answer. Your calculators are fine for the answers. Okay. So let's do this. Finish it up. I do have a couple of things that I do want to talk about as well that are not, well, they are kind of related to what we're doing, but directly related to other stuff as well. So the first thing is, we do like we did at the very beginning. I want to know where they cross each other. I want to know the y coordinates. The x coordinates I don't need, but the y coordinates I do. I have a system of equations. X equals this, x equals that, they equal each other. Y squared minus 4y plus 10 equals negative y squared plus 9y minus 5. Quadratic, set it equal to 0. Add y squared, subtract 9y, and add 5 to both sides. You get 2y squared minus 13y plus 15 is equal to 0. Now, if this is a calculator portion of the AP exam, or this chapter for me, use your solver. Your calculators have solvers on them that will solve that equation for you. Your calculator should have two types of solvers. It should have one straight up. Actually, it should say 3. And I know that if you have the Casio, there are 3 types of equations you can solve. You can solve a system of linear equations just by typing in the coefficients in the program they have. You can do polynomials just by telling it what power you have, what degree it is, and then typing in the coefficients. Okay? And it will actually give you fractional answers. Or you can use the solver menu, which is you type in the equation and it gives you the solutions where they cross each other. You are required to know how to do 4 things on your calculator for the AP test. Graph an equation. Numeric derivative, numeric integral, use the solver. I have seen it on the AP test in the past where they give you 2 equations, and the only way you can find the point of intersection is by using the solver menu, or by graphing the 2 and where they intersect. Using your calculator is the only way to do it, because it's like some decimal out to like 5, 6 decimal places where they cross. It's not a whole number. It's not an easy fraction. It's some nasty number. You know, the natural log of this is set equal to e to the 4x or some crap like that. Okay. Now, do this one by hand. You get 2y minus 3. Y minus 5 is equal to 0. So your points of intersection are 1.5 and 5. Or 3/2 and 5. I use 1.5 type in the calculator. It's easier. So they have the integral from 1.5 to 5 of negative y squared plus 9y minus 5 minus y squared minus 4y plus 10 dy. And my suggestion is that you combine them up. Even if you're typing it in your calculator just to make it shorter and easier to type in your calculator. Seriously, I would do that. Combine them up into one first. It's easier to type it in without screwing up. And then my answer I got was 14.296, what I got.
Yeah.
And by the way, the rules for AP 2916, sorry, 2916. Okay, let's talk about this answer here, 2916, because this is what I expect in here, and it is the standard rule for AP. You need to give me 3 decimal places, truncated or rounded. And truncated or rounded, Mr. Orris, what do you mean by that? I hear you cry. Here's what I mean by truncated or rounded. So this is my answer, and technically it goes on from here. So truncated means I cut it off. 14.291. It just cut it off with 3 decimal places. Rounded would be 14.292. Either answer would be acceptable. Now, if it was rounded down, truncated, and rounded, it's the same answer. So it's kind of funny. On the AP exam, when we start doing practice questions, you will grade your answers. And you will see, sometimes you'll see it like that. Sometimes you'll only see one. When you see it like that, that means truncated and rounded are 2 different things. If you see one, that means it's the same answer either way you answer it. You may always go more than 3 decimal places in your answer. So if you'd given the first one 14.2916, you'd be fine. If you go less, if you said that was 14.29, you would not get the answer point on the AP exam. Seriously, they will not do that. The only time they take less than 3 decimal places is if they tell you to. Round it off to the nearest car. That means a whole number. Round it off to the nearest 100 people. That means it's to the nearest hundredths. Otherwise, they don't tell you, they want 3 decimal places. The only time you don't do 3 decimal places is if it comes out exact less than 3 decimal places. So if it comes out exactly 10, you put 10. When it's 10 point blah, 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 no rounding off to 10. They will not give you the points. And they will dock you points if you use less than that at any other place in the test. So let's say you have to find the bounds using your calculator. And this is, let's say this was one of the bounds. If you rounded it off, you would not get the points for having the bounds. And if you round it off, your answer will not be correct to 3 decimal places either. Always carry more than 3 decimal places when doing work on your calculator. If you ever write down a number as an interim amount, let's say you work something out, you write it down, and you're going to use that number later and you're doing a calculation, write down as many freaking decimal places as you can. Because if you round off early, your final answer may be off by more than 1,000th, which means you will not get the points. And that's called round-off error. Because you round off, you have an error because you rounded off too soon. You rounded off in your interim work, you will not get the correct answer.
So you can have 14.5.
291. No, they don't. If you do more than 3 decimal places, then they will just go to the first 3 and stop. Does that make sense? Yeah. Yeah, they go to the first 3 and then stop. So if you write more than 3, you know you're going to be accurate to 3 because you copy down more than 3 off your calculator, you'll be accurate to more than 3. But the other thing, like I said, and do not just poo-poo this, you can't round off too soon. If you find bounds in your calculator, we'll have some example problems later. And when they do theirs, when they give the answer key, you'll see it'll be like 6 or 7 decimal places. They expect you to go out that far to do your work with. They don't expect that for the final answer, but they expect you to work with a more accurate number than your final answer is going to be. If you round off too soon, your answer is going to be off. And literally, if you had 14.293, you would not get the answer point. Literally. They won't give it to you. Okay? And there are some things that they're harsh about. Most of them is fairly straightforward, and the answer is one of the numbers that they're pretty harsh about. There is one exception. If you got a wrong number in one part of the test, let's say you solved part A, and you got a particular value that was wrong, but if you use it, but it was relatively close. If you use that incorrect answer correctly in part B, they will give you the point. Because if you use, they try to separate the two. So if you use your wrong answer correctly, they will actually sit down and figure out what it should be using your wrong number. And if it comes up with that, then they'll give you that point. Because that separates the two. Not getting this one right should not determine that you don't get the points there if it's a different problem just using the answer from above. Okay, that's one of the times where they're actually pretty, I actually like that. That one's a good one. Or if you use your wrong answer correctly to solve part B, wrong answer from A to solve part B, and you use it correctly in part B, but you still get the wrong answer because you used the wrong number, you're okay if you use it correctly. Okay. Any questions? Okay. Once again, take your time going through these problems. Draw diagrams. If a diagram is given in your textbook, copy the diagram on your paper. You want to be able to make sure you get it right.